Welcome to the third video of this series. After creating prismatic components in the last two videos, today we will focus on a rotationally symmetric part, the pin. We will get to know the new commands, rotation and cylinder. There are different approaches to creating a rotationally symmetrical body. In this video, we will go through three methods together and compare them at the end. The pin is a simple cylinder with a chamfer at both ends. It is important to mention that this pin is actually a standard part and would be available in component libraries. Nevertheless, we are creating it manually to learn the different methods in Fusion. At the beginning, we create a new design as usual. This time, we use the plus symbol in the top right to skip the step of going through the File button. It is advisable again to save the component right at the beginning and assign a meaningful name. Saving can be done either as usual using the Save button or with the shortcut control NS. If the preset folder is not correct, the desired storage location can be selected from the drop-down menu. Now the file for the pin has been added to our folder. Again, we start our design with the sketch in the ZX plane. Instead of a rectangle, we will draw a circle around the origin this time. To do this, go to the menu to Create, Circle, Center, Diameter Circle. We give the circle a diameter of 4 millimeters and confirm the entry with Enter. We can now finish the sketch and simultaneously start the extrusion by using the shortcut E. The pin should be 13 millimeters long. We enter this value and confirm it with Enter. Now all that's missing are the chamfers. Since we will be using the chamfer tool more frequently for further construction, we can add it directly to our toolbar. To do this, open the Modify menu and click on the three dots next to the chamfer tool. By checking the box to Pin to Toolbox, the tool will be permanently shown in the top bar. Now we select the two edges of the cylinder and set a chamfer of 0.5 millimeters. With that, the component is already finished. However, there is an alternative method for rotationally symmetric components like this pin. Rotating a profile around an axis. First, we hide the pin we just created in the browser in the folder body and start with the second method. This time, we start with a sketch on the YZ plane. With this method, we draw the cross-section of the pin and rotate it around the central axis. First, we draw a rectangle by choosing the two-point rectangle function. The first point is placed on the origin and the second can be placed anywhere on the sketching plane. With that, we've created an undimensioned rectangle. Since we want to create a rotationally symmetrical component from it, we select the bottom line of the rectangle and change it to a center line in the sketch palette. Now, in the Create menu, we select the option Sketch Dimension. With this tool, we can add the missing dimensions. First, we dimension the diameter. We click on the center line and the parallel, and specify 4 millimeters as the diameter. The Dimension tool remains selected and we measure the length of the pin as 13 millimeters. This can be done in two ways. Either we directly measure the line that should be 13 millimeters long, or we measure the length by selecting the two outer edges and defining the distance between them. Change-friendly dimensioning means that dimensions are set in such a way that they do not shift when later changes are made to the model. For example, if we later add a shoulder to the shaft, the total length of the pin remains constant because it is defined by the distance between the edges. New geometries can be placed within the existing dimension without changing the total length. This approach makes the model more flexible and allows for quick, efficient adjustments without having to redimension each individual line. It also reduces the likelihood of errors during design changes. We can now complete the sketch. To create a solid body from our rotational contour, we use the Revolve command. To find this command more quickly for future rotationally symmetric parts, we create our own shortcut. To do this, we go to the Create menu and click on the three dots next to the Rotate command. Here we select the option Change Shortcut. In the next step, we simply press the key that should serve as the new shortcut for the command, in this case, the W, and confirm the entry. From now on, we can start the Rotate command at any time by pressing the W key. We select the rotation profile and the center line as the axis. The cylinder is now created by rotating. We have just created the same cylinder as before, but in a fundamentally different way. We could add the missing chamfers of 0.5 millimeter again in the same way. We hide the sketch again and now try a third method that is suitable for simple bodies like this. The cylinder tool. For this, we can directly select the cylinder command in the Create menu or simply search for the command. Press the shortcut S and enter cylinder in the search field. This way you can quickly find the command and use it directly. Afterwards, we select the ZX plane and set the origin as the center. Now we enter the diameter of 4 millimeters and the height of 13 millimeters. The cylinder is created directly. Here we can also add the chamfers as usual. Finally, we compare the three methods with each other. The extrusion of the circle is a quick and straightforward way to create rotationally symmetrical components like our pin. Rotation is particularly suitable for more complex rotational bodies with varying profiles, allowing for very versatile shapes. You'll learn more about this in the next video. The cylinder tool is especially efficient for simple geometries because cylinders can be created without a prior sketch with just a few clicks. Since we now have 3 identical pins, we should delete 2 of them. To do this, we can remove 2 of the pins in the browser under Bodies, or delete the corresponding steps in the construction history. To finish, we change the material of the component to bronze. For this, we go to the toolbar, select material, and choose bronze from the material library. The material properties such as mass and density are now automatically adjusted. We save our component again. You can do this either using the Save button or with the shortcut Ctrl and S. In this video, we learned about 3 different methods to create a rotationally symmetric body. In the next video, we will take a closer look at the rotate function to create a more complex rotationally symmetric component. Until then, have fun exploring.